Okay, so I wanted to give you a quick update of what I have done with my grader control, which you have seen in the last video. So today I'm going to show you my wooden recreation of my grader. So it has the same kinematics pretty much, with the servos and the circle recreated with wood, and the accelerometer or gyroscope inertial measurement unit sits here. The Arduino sits there, as you've seen on the aluminium full grader, and here I have my own 3-channel servo tester. So I'm going to fire it up by connecting the freshly charged 6-volt battery. So there we are. We see 3 channels. So what I'm doing here is preparing the electronics for what I want to use in the grader eventually. So in the last video I showed you the control, the automatic control of the blade level, and in the grader I of course not only want to have it in the automatic control mode, I also want to have a manual mode, and I might want to have a dedicated 0, so horizontal, and I might want to flip the sign of the level if I'm going with the grader in one direction and then not reversing and doing the next line, but rather turning around and do a pass in the other direction. Then I need to flip the sign of my grade. So yeah, all of these I want to do, but with my 2-Turner G9X I'm already at 2 times 8, all 16 channels. So what am I supposed to do? Well, I'm using a channel of lesser importance, and I'm using the first half of that channel to control the clamping servo. So this will be the clamping servo on the grader saddle. The saddle is the thing on my full model that rotates around the front frame, and similar to the full-size graders, I have a clamping mechanism that locks this saddle in place. And this is what this servo or another servo is going to do. So I have this control here, so we can, well, you can't probably see, but up to 1500 microseconds, all that happens is this adjusts the clamping, or will adjust the clamping, and then I have the control for the grader, for the full mold board. As you can see, it works really nicely. I have roll and I have lift, and in this instance it's not automatic, it's purely manual. And that is important because during the clamping operation I actually need to use these servos to turn the saddle. So I unclamp the saddle, and then I use these to turn the saddle by pushing against the ground, turn the saddle to where I want it, and then clamp it. So I need to be in manual mode there, otherwise things would be really annoying. So and then when I get to 1500 microseconds, which is normally the center, I am stopping the servo, so this will be in its end position. So even though I'm in the middle of the adjustment range of that pot, that servo is already at the end of its stroke, so that I can get the best clamping range, because it goes from full left to full right, so I have the best clamping. And the exact end stops I can later adjust in the Arduino code that is running here. So what happens once this dial goes beyond 1500, which is normally the center of the range? Well, at this position, as I said, the clamping servo is locked, and I can still do the manual adjustments, as you see. And then if I increase this further, again, nothing happens with the clamping servo because it's now in the use position, and I go to this value, you will see that I can still lift and lower, but if I do the sideways motion that usually creates a roll, nothing happens. And that is because this is the dedicated 0, that's the dedicated horizontal, so as you can see it finds the position. So I currently have the controls to be set quite mild, but yeah, you can see how it works. And then if I increase that this control channel even more, then I will get to the point where we have pretty much the operation that you've seen before. The clamping servo still clamping, repeating myself, and now we have lower and lift as before, and we have now that I can set a value different than 0, and so I can set the grade as I want. So in the last position is changing the sign, so going from this orientation, basically mirroring the whole thing, keeping the degrees the same but with the other sign. So and for that I again use this adjuster. I will go to the absolute end, and while I'm in that end nothing will happen, as you can see. It's now at the end, but as soon as I go out of this end of the range, you should see that the controller flips the sign and automatically adjusts to the other side. So if the grader is reversing, then you can see that I can leave the grade correctly. So yeah, that's pretty much a working prototype. I will introduce, so currently basically what that does is the first half of this potentiometer is for the clamping servo, and the second half sets my different control methods. And I will probably have a little bit of a spacing in between, so that it's, you know, if there is a momentary glitch in the signal, that it doesn't destroy any or that it doesn't upset the control. But yeah, it works really well, as you can see. And yeah, with that said, I think I'm at the end of this short video. Well, I say short, but I'm always babbling, so we'll see how much I cut it down. And yeah, thank you for watching, and until next time, bye bye.